JEE aspirants, listen up. This is your data-driven physics plan for 2025. No fluff, no distractions, just what moves your rank. In the next minutes, I'll show you exactly where marks come from and how to convert them consistently. Here's what you'll get. Real weightage insights, a laser focus on mechanics to anchor your score, a clean path to mastering electricity and magnetism, quick wins from modern physics, and an actionable revision pyramid that cuts noise and boosts accuracy. Roadmap for today: Section 1, Mechanics. Section 2, Electricity and Magnetism. Section 3, Optics. Section 4, Modern Physics. Section 5, Thermodynamics and Waves. Section 6, 5-year trend analysis and your weekly strategy. Grab a pen, take notes, and build your playbook as we go. You're watching Physics Mint by Supreeth BS. Let's lock in your physics advantage, starting now. All right, let's dive straight into the heart of JEE physics, mechanics. If you're aiming for a top rank, this is the section you absolutely must conquer. Why? Because mechanics isn't just a chapter, it's the foundation upon which nearly half the syllabus is built. Year after year, from 2020 right through to 2024, it has consistently commanded a massive 30–35% of the total marks in both JEE Main and Advanced. That's not just a few questions. It's a significant chunk of your final score, often deciding your rank and even your campus. Think of it this way. For every 3 physics questions you face, 1 is likely to be from mechanics. Mastering it is not optional. It's your ticket to a high percentile. So, where do you start? The journey begins with the absolute bedrock, Newton's laws of motion and friction. This is your toolkit. Every complex problem, from a block sliding down a wedge to a multi-pulley system, is solved by meticulously applying these fundamental laws. The single most critical skill here is drawing accurate free body diagrams, or FBDs. Never, ever skip this step. Isolate each body, identify every single force acting on it. Gravity, normal reaction, tension, friction, and resolve them along your chosen axes. This systematic approach turns a confusing problem into a straightforward set of equations. Remember to be careful with pseudo-forces in non-inertial frames. They are a common source of error, but a powerful tool when used correctly. Once you're comfortable with forces, we level up to a more elegant and often faster approach: work, energy, and power. The work-energy theorem is your golden rule here. It states that the net work done on an object equals the change in its kinetic energy. This principle allows you to bypass detailed force analysis and solve problems by looking at the initial and final states of the system. A key distinction to master is between conservative forces, like gravity and spring force, and non-conservative forces, like friction. When only conservative forces are at play, mechanical energy is conserved, which simplifies things immensely. But in most real-world and JEE problems, you'll have friction doing negative work, dissipating energy from the system. Your job is to account for this energy loss precisely. Now we enter the domain that separates the good from the great: rotational mechanics. This is where many students stumble, but it's also where you can gain a massive competitive edge. The key is to see the parallels with linear motion. Force becomes torque. Mass becomes moment of inertia. Linear momentum becomes angular momentum. The equation F for ma becomes torque equals I alpha. Master the calculation of moment of inertia for standard shapes, rings, disks, spheres, and rods, using the parallel and perpendicular axis theorems. These are your building blocks for solving any rotational problem. Finally, we have gravitation. This chapter is relatively formula-based but conceptually rich. You'll find questions are often direct applications of formulas for gravitational force, potential, and field strength. Pay special attention to Kepler's laws, especially the third law, T/2, proportional to R3, which is a favorite for comparison-style questions. Also, master the concepts of orbital velocity and escape velocity. A very common problem type involves calculating the energy required to move a satellite from one orbit to another. The key here is to calculate the total energy, which is negative, in the initial and final orbits, and find the difference. In JEE Advanced, expect gravitation to be combined with rotational mechanics. For instance, a problem about the angular momentum of a planet in an elliptical orbit, testing your knowledge of conservation of angular momentum. By breaking mechanics down into these core pillars and mastering the connections between them, you're not just preparing for 35% of the paper. You're building an unshakable problem-solving foundation for all of JEE physics. Electricity and magnetism together form the second major block, averaging 25 to 28% weightage. Topics like current, electricity, and capacitors dominate JEE Main, while JEE Advanced frequently tests magnetic effects and electromagnetic induction. The key to mastering this section is understanding field concepts and practicing derivation-based numericals. Optics contributes roughly 10 to 12% of physics marks. Ray optics is a must-master topic for JEE Main, focusing on mirrors, lenses, and image formation. In Advanced, wave optics concepts like interference and diffraction are common. Practice diagram-based numerical problems and understand formula derivations clearly. Modern physics shows rising importance, around 15% weightage in recent years. Topics like photoelectric effect, atomic structure, and nuclear physics appear almost every year. These are formula-based and scoring, so focus on conceptual clarity and quick problem solving. Together, these topics contribute 10 to 12% on average. Thermodynamics is conceptual and often paired with kinetic theory. Waves questions in JEE Advanced emphasize superposition and resonance. Strong understanding of graphs and wave equations helps secure easy marks. Alright, we've journeyed through the core concepts of JEE physics, from the tangible world of mechanics to the invisible forces of E&M and the quantum weirdness of modern physics. But knowing the syllabus is only half the battle. The other half, knowing the battlefield itself. This is where strategy comes in, and it's what separates the top rankers from the rest. Welcome to the most crucial part of our discussion, the 5-year trend analysis and your winning strategy for JEE 2025. Let's look at the data. From 2020 to 2024, the structure of the JEE physics paper has shown a remarkable consistency. There are no wild surprises, which is great news for a strategic aspirant like you. The two titans, mechanics and electricity and magnetism, have consistently dominated the paper, together accounting for over half the questions. This isn't a coincidence. These topics are the bedrock of classical physics, and their principles are woven into almost every other chapter. But here's the interesting part of the trend. We've seen a slight but steady growth in the weightage of modern physics. Simultaneously, there's been a marginal decline in the number of standalone questions from waves. What does this tell us? The examiners are favoring topics that are high-scoring and conceptually direct. Modern physics questions are often less complex and more formula-based, making them a goldmine for boosting your score. The decline in waves doesn't mean you should ignore it, but rather understand that it might be integrated with other topics like optics. So, how do we translate this data into a concrete action plan for 2025? We use it to build our revision pyramid. Your time is your most valuable asset, and it needs to be invested wisely. Based on this 5-year trend, here is the ideal allocation of your revision efforts. First, the foundation. Mechanics gets 30% of your revision time, and E&M gets 25%. That's 55% of your effort dedicated to mastering these two giants. This is non-negotiable. For every 10 hours you study, 5.5 should be spent here. Next, the strategic booster. Modern physics gets a solid 15%. This is your rank climbing section. It's relatively easier, highly predictable, and gives you the maximum return on your time investment. Then, the stable pillars. Optics and thermodynamics combined with waves each get 10% of your focus. These are reliable self-contained units that provide consistent marks. Finally, the finishing touch. The remaining 10% goes to miscellaneous topics. This includes units and dimensions, errors, experimental physics, and other smaller chapters. Never underestimate these. They are the low-hanging fruit, the easiest marks you will get in the entire paper. Now let's talk about your practice rhythm. Your preparation should follow a 2-beat cycle: conceptual understanding, then speed and accuracy practice. First, when you revise a chapter, focus only on the why. Why does this formula work? What is the core principle? Solve 10-15 high-quality conceptual questions, even if it takes time. Once the concept is locked in, switch gears. The next phase is all about volume and speed. Solve 30-40 questions under timed conditions. Your goal here is not just to get the right answer, but to get it quickly. This dual approach ensures you build both a strong foundation and the exam temperament required to succeed. This brings us to the final piece of the puzzle, your mock test strategy. Mock tests are not just for checking your score, they are for refining your strategy. Here's a simple yet powerful framework, the 3-pass technique. In your first pass, which should take about 20-25 minutes, you scan the entire paper and solve only the easiest, direct formula questions. These are your confidence builders. You are essentially harvesting all the low-hanging fruit first. In your second pass, lasting around 30-35 minutes, you tackle the medium difficulty questions. These require some thought and calculation, but are well within your ability. You've already secured some marks, so you can approach these with a calmer mind. The final pass is for the tough nuts, the questions that are either very lengthy or conceptually tricky. With the time remaining, you attempt these. The beauty of this method is that you never get stuck on a difficult question at the beginning and waste precious time. You maximize your score by securing all the easy and medium marks before fighting the hard battles. After every single mock test, you must perform a thorough analysis. Categorize every mistake you made. Was it a conceptual error, meaning you didn't know the topic? Was it a silly mistake, like a calculation error or misreading the question? Or was it a time management issue, where you knew the answer but didn't have time? This analysis is your feedback loop. It tells you exactly what to fix before the next test. Is your foundation weak, or is your execution during the exam flawed? By combining the 5-year trend data, a structured revision plan, a smart practice rhythm, and a strategic mock test approach, you are no longer just studying physics. You are engineering your success. You are preparing to win. This is Physics Mint by Supreet BS.